Hello and welcome to C and Data Structures training session. This is the first session of the series. In this session, we are going to cover about some basics of computers, so that we'll get started with very basic things, and then we'll go towards the advanced stages. So, in this session, we are going to cover about very basics about what is computers, how input, storage, processing, and output devices works, uh, what all are the computer languages, uh, number system that is followed in computers, ASCII format, and a little bit about compiler and interpreter. This is a very basic diagram how each and every component of a computer talks to each other. There are various components in a single computer. One is called CPU, which does the processing. There's a memory location where it has storage and uh, persistence of data persistence. Then we have physical or the external hard disks. So these all comprises of the storage, where this is a primary memory, which is kind of RAM or cache, and this is the secondary memory, which is kind of external hard disk. And this is a communication channel, which is called BUS. Every component talks through this communication channel. Then we have input controller and input devices, output controller and output devices. So any communication that happens from one component to other component happens through the communication channel. If I want to store something in the hard disk, I need to go to the communication channel. If I want to print something in the output, I need to go through the communication channel, and so on. So, what is control processing unit, or CPU? CPU comprises of this is the area where where if you zoom in into CPU, we will have a vision of this, which comprises of ALU. Uh, ALU is nothing but arithmetical logical unit. Uh, uh, like here, ALU is nothing but arithmetical logical unit. CU is nothing but control unit, and these are the registers which stores data for immediate computation. So all the control unit and ALU uses the register to do the calculation, and the CPU talks with input devices, output devices, primary storage and secondary storage. So let's talk about ALU, CU and registers in detail. What is arithmetic? What is ALU? Arithmetic logical unit. So all the arithmetic and logical operation like addition, subtraction, comparison, etc. are performed in this unit. Um, any computation related problem, if computer has to solve a complex computation related problem, it will be boiled down to arithmetic problem, and then the ALU will take care of solving the arithmetic problem and giving the output. Control unit controls the working of CPU. Basically, it controls uh, where to get the data, where to put the data, how to switch between the registers and all. Registers are special memory unit inside CPU to speed up the rate of data transfer within CPU. So registers are memory unit which is local to CPU. So for any kind of computation, first the data is transferred to the registers, and then the and then it is given to ALU to perform the operation. Mostly this is done in either machine level language or assembly level language, where we we take value out of the register, do some computation, store the result in the register and all the stuff. So we are not going to much detail, but this is just for your understanding that these are the components which mainly are responsible for processing power of your computer. So primary memory is has many types. One is random access memory, which is RAM. RAM is mainly static RAM, DRAM, say dynamic RAM, or QRAM, which is quad RAM. Uh, uh, Mostly this, why this is called primary memory is because one thing is that it's a digital memory, and it is fast to access, and any data stored in the RAM can be calculated and accessed fast as compared to the data stored in the hard disk or secondary storage. ROM, read-only memory. So read-only memory consists of your hardware's configuration, which your hardware vendor does not want you to disturb. So it puts those data in the read-only part, where nobody can alter the configuration. So ROM is evolved. Uh, Earlier, it was only programmable ROM, like it can be programmed only once. Um, then it comes to EPROM, that is erasable and programmable ROM. So, when as part of a second level of evolution, we can erase the data from ROM and rewrite the data into the ROM. Uh, Third part is EEPROM, which is electrically erased and programmable ROM, where you can short the ROM, erase the data, and reprogram it. So mostly when you buy your computer or laptop, and it comes up with some default OS which is there in the system, so it resides in your ROM, and whatever upgrades happens, it goes to that space only. Cache memory is very high speed memory and acts like as an interface to CPU and primary memory. So cache is like very frequently used data. So what computer does is it maintains some data which is more frequently used, so that uh, it does not have to go to the primary memory to fetch the data. Cache is very fast to access, and it has a limited space. So OS and the memory management programs and the stuff written in the OS is designed in such a way that we utilize cache and RAM very efficiently, so that we have maximum output from our computer system. So primary memory is something like we have a block of addresses, and we store the data in these blocks. For example, we store some words in these blocks, which can be accessed through CPU. Uh, so memory terms, so here is like 1 bit, which either 0 or 1. Then 1 byte consists of 8 bits. 1 kilobyte consists of 1024 bytes. 1 megabyte consists of 1024 KB. 1 GB consists of 1024 MB, and 1 TB consists of 1024 GB, and 1 petabyte consists of 1024 TB. Okay. About input devices. So input devices are keyboard, mouse, scanner, trackball, and all other digital type of input devices from which we can get the data from and do some processing. Output devices are either a screen, camera, printer, audio, video, and speakers, and there are n number of sets of output devices where we transfer the data from out of the computer. Storage devices, these are the storage list. These are the very basic storage devices like flash memory, floppy, hard disk, and a number of storage devices. These are good to store the data. So languages. So what all are the languages supported by computer? Computer supports low-level languages, which is machine level language. Machine level language is nothing but language which is written in bits format 0101. So it is just understood by machines. It's very difficult to for human to understand machine level language. So that's why its name is given as machine level language. Assembly level language is one level of abstraction over machine level language, where we have some the operations that we can perform like add, sub, and all the stuff. So uh, these these can be easily understood by humans, and we can do some programming in assembly language uh, with the help of registers and all those stuff that we have already mentioned. High level language. So high level language is one more layer of abstraction over um, assembly level language. So for example, high level language has is kind of procedural language. It has functions, it can do object oriented uh, things. It depends upon what kind of language you choose. Language in sense of the programming language. So here in this course we are understanding C. So C is a high level language and it's a procedural language. So C does not support object oriented principles. So but to understand like why it is categorized as high level language, because the program that we write in C will ultimately be converted to an assembly language, and assembly language programs will ultimately be converted to a machine language. So we need not have to worry about the conversion of our program from high level to a machine level. We just write our instruction program in C language and we compile it, and the process compilation process complete process of compiling will convert our code.c file to output file. So whenever we write a program in C, it is stored in a it is written in .c file in some format which we will understand throughout this session and further sessions to follow. So number system. So these are the number systems which are understood by the computer. Uh, one is binary conversion, binary number system. So in binary, everything is represented in 0 and 1. In octal, everything is represented in 0, 1, 2, 3, 4, 5, 6, 7. Similarly, hexadecimal has more range. Everything is represented in 0 to F. And similarly, decimal is represented from 0 to 9. Let's have one example. For example, let's convert decimal to binary. So for example, how we convert decimal to binary. Generally, every number, if you see how we represent 1 in uh, binary format is 2 to the power 0, like the 2 to the power 0 is equal to 1. So it will be how 1 is represented is 1 into 2 to the power 0, and 0 into 2 to the power everything else will be 0, and here we have 1, so 1 into 2 to the power 0. How we represent 2 in binary? And 2 in binary will be represented as 1 into 2 to the power 1, because 2 to the power 1 is 2, so 1 into 2 to the power 1, and everything else from here to here, and this is all is 0. So how 2 is represented? 0 0 0 0 0 0 0 0 1 0. So we need not have to think about the zeros at the left hand side, so we can omit this, but 0 at the right hand side are important. So to represent 2 in binary, we use 1 0. So 1 0 is represented as 2 in binary. Let's take one more number, say 3. How 3 is represented in binary? 3 is equal to 2 plus 1. So we will be having 1 into 2, 2 to the power 0, 1 into 2 to the power 1, and rest all are 0. So how 3 is represented in binary? 3 is represented as 1 1. Similarly, we need to do the conversion. There is one more way to convert a number in binary, is keep on dividing the number by 2 and write down the modulus at each step and reverse the modulus. So this will give us the binary conversion. So for example, how 46 is represented in C? So 46 divided by 2 is 23, and modulus is 0, so we have 0 here, and 23 is our result. Now 23 divided by 2 is equal to 11, and modulus is 1, so 1 is stored here, and we have 11 left. 11 divided by 2 is 5, and modulus is 1, so 1 is stored here, and 5 is left. 5 divided by 2 is equal to 2, so and remainder is 1, so 1 is given here. We are left with 2. 2 divided by 2 is 1, and the remainder is 0, so 0 is kept here. We left is all we left is 1. 1 divided by 2 is 0, and the remainder is 1, so 1 is kept here. So if you want to represent 46 in binary, just read all the modulus in reverse order. So 1 0 1 1 1 0. This is the binary conversion of number 46. Okay. So what is ASCII format? ASCII format stands for American Standard Code for Information Exchange. It's a 7-bit character code where every single bit represents a unique character. So we have each and every character is having some code. So for example, A is having some code, small a is having some code, and so on. And these are converted into the machine readable language, machine readable instruction in bits, and here on it is understand. So this is a standard where each and every language follows, so that it will be easy to understand what is going on. So what is a compiler and interpreter? Compiler is nothing but it compiles your program, and it searches for errors in your program. It does a lot more stuff, but what it does is it lists down all the errors of your program in one go. So uh, and what is interpreter? Interpreter also checks your program for error, but it stops at, at a place where the first error occurs. So suppose it's scanning from top to bottom, wherever it finds a first error, it stops. It does not execute you. It does not compile your program further. Whereas compile scans through the complete code and finds out what all errors are there and lists you. So this is how C compiler works. So here it is written CPV, but fairly C is also the same. Uh, the C files are given to compiler, and it is first. Now the compiler has various stages. Uh, One stage is lexical analysis, like it converts your lines or converts your words into token. Then it does the syntax analysis. Syntax analysis is nothing but it converts your token, or it checks your token with correct syntax, whether any word is wrong or not, or you are not, if you are using correct syntax. And semantic analysis, then it arranges the word and uh, checks whether the combination of word is forming any meaning or not. And if everything is successful, we get an object or output file, which is given to a linker. Linker will link multiple output files and give us the executable files. Similarly, interpreter also takes the source code, does the lexical analysis and syntax analysis, semantic analysis, does code generation. It again does an intermediate language code, uh, and it's given to an interpreter, which publishes the result. So if any program is break because we have some error in one line, we need to correct it, submit it again. This process is followed again followed, and so on. So this is the basic difference between compiler and interpreter.
I'm sure you enjoyed learning from this video. Please like the video, and if you have any doubts regarding this video, please comment us in the comment section, and don't forget to subscribe to our channel for more such informative videos. Do look out for other related videos in our playlist. For more information, visit our website now. Keep learning with Intellipaat.